This rain was made entirely in Unreal Engine, no plugins, just Niagara. Hi everyone, in this tutorial we're going to create rain using Niagara in Unreal Engine. First, we create a Niagara system. Then we choose empty, so we start without any template. Next, we add an emitter. An emitter defines how particles are created, simulated, and rendered. It controls the spawn rate, lifetime, movement, and overall behavior of the particles. Now we go to emitter update, which controls the overall behavior of the emitter and runs every frame. We add a spawn rate so particles are generated every second. We add the Niagara system to the scene so we can see the changes live. To give the particle spawn a shape, we add shape location to particle spawn. As you can see, particles are spawning in a sphere shape, but for rain we will use a box instead. By scaling it, we create a flat area for rain generation. Next, using initialize particle, we make the particle smaller. Now it's time to add velocity. Velocity is added to give particles an initial movement direction and speed. In the velocity settings, we add a random range vector so that by giving it variation, the particles have random movement. For rain, we use a negative z velocity so the particles move downward toward the ground. Now, to make the rain fall downward, we use solve forces and velocity. Also, to make sure the rain direction is correct and aligned with the velocity, we set the sprite render alignment to velocity. Then we add mesh collision, and the particles start bouncing in different directions. To make sure they are completely removed after collision, we use kill particles and enable has collided. Now, to make the effect more realistic, we create splashes, so we add a minimal emitter. A minimal emitter is a lightweight emitter with only essential modules. It's used for simple effects like rain splashes to improve performance. To create a connection between these two emitters, we add generate collision event to the main rain emitter. We add generate collision event so the main rain emitter can send collision data to the splash emitter. This allows splash particles to spawn exactly where raindrops hit the surface. At this point, we get an error. To fix it, we enable requires persistent IDs. Some Niagara event systems, like collision events, need a stable, unique ID for each particle to track it correctly across frames. Enabling requires persistent IDs gives every particle a persistent ID, so the event handler can reliably reference the correct particle and the error disappears. Now, to let the rain communicate with the minimal emitter, we use an event handler and set it to spawn particles so it spawns particles for us. For example, we set the spawn count to 15. To make the splash particles react to collision, we add receive collision event, but nothing happens yet. The reason is that in the event handler settings, we must select event handler properties correctly. As you can see, the particles stay on the surface and are too large. This part should be familiar. To make them smaller, we reduce the particle size in particle spawn. We add velocity again, but this time we set it to cone mode. Cone velocity is used so splash particles spread outward in multiple directions from the impact point instead of moving in a single straight line. This creates a more realistic splash effect after collision. Now that we have splashes, we reduce their lifetime to make the effect more natural. As you can see, the splashes are stretched toward one direction, which is due to the cone settings. If we set X to 0 and Y to 1, the direction changes. If we set Z to 1, the particles spread upward. If we set all axes to 1, they spread in 3 directions, and depending on the cone angle, the splash behavior changes. We can also adjust the velocity strength. Finally, we set Z to 1 and increase gravity to get a better, more realistic result. We also make the particles even smaller. At the end, we slightly adjust the Y angle so the splashes align with the rain direction, but be careful not to overdo it. Lastly, if the white color of the particles feels too strong, you can go to Initialize Particle, set Color Mode to Direct Set, and reduce the alpha value so it looks closer to water. Thanks so much for watching the video. If you enjoyed it, don't forget to like, subscribe, and leave a comment. It really helps the channel and means a lot. See you in the next one.